Yeah. Okay. I think I wasn't live, but I think we're live now. So okay. Let me see. Here we go. So I just curled down the latest kind so that I could get a 1.24 cluster. So I think I have one now. kubectl version. Okay, so I have a 1.24 version, and I have a client from 1.18. Let me see. Yeah. So let's do let me add let's see here. So I have the KEP here, and it looks like Chris just joined.
Yeah, how you doing?
Chris, your microphone's working too.
It is, yeah.
So I didn't. So this is actually a good one for you to join because we kind of sent the tweet out at like kind of last minute and forgot to tell folks to retweet it. So this will be a pretty casual episode. I don't know how many people are going to show up. So this is episode, I think, 28. I don't know. But anyways, what we're going to do today is Chris is going to start helping us to, some folks are starting to roll in, so that's cool. So if folks are coming in, feel free to say hello and let us know where you're coming from. Chris is going to start helping us host a few shows. So Chris, while I get started over here and do some notes, why don't you introduce yourself to people and let us know what you're going to be showing us?
Yeah, so my name is obviously Chris Grice. I'm a solutions architect on the with VMware on the Avi AKO offering. So I'll start off probably, showing some AKO stuff, some AMKO stuff, looking at ingress generally, and just going from there, really. Thanks for inviting us. Yeah,
cool.
This is the first one of these I've done as a live, whatever you call it.
Do you feel like you're famous right now? What? So we're gonna do two things. So we're gonna do one thing. Oh, here's my favorite part about StreamYard. This is something we do, Chris. We type in here, "Hi, Chris. Thank you." Okay, and then we can do this. We can click these and bloop. See how it comes up?
I see, yeah.
So that's our big deal. That's what we do here. So writing the KPNG KEP, and then let's do 1.24, right? So what we're going to do today is we're not going heavy on the networking stuff today, but we can if folks want to ask stuff. David, what's up? Hello, looking like episode 27. Yeah, 27. I think I kind of made, yeah. So, by the way, if folks are on Twitter, I don't know, I guess people are leaving Twitter nowadays, but not me. But if folks want, I'll give you the link here. Folks want to retweet today's show so we can get more people to come, here is the link to it. And then so Chris is coming. Okay, so 1.24. So I think what we'll start with is, because KubeCon's coming up, I thought it might be nice to sort of look at what went into 1.24, because the official release came out not too long ago, and I don't think we really ever talked about it on the show. So Docker shim removal, that's nothing new technology-wise, but it's official now. We've talked about that before. CSI volume, health monitoring, being able to load a sidecar. So this article is from Sysdig, and so Being able to load a sidecar that checks for the health of persistent volumes. Now cluster administrators will be able to react better to faster events like persistent volumes being deleted outside of Kubernetes. So I don't understand what this feature is, like when I first look at it. Because like, the first thing I think is, why do I need an API change for a sidecar? That's not something that I need an API change for. So I guess they have a CSI volume health field. CSI drivers can now load an external controller as a sidecar that will check for volume health and provide node get volume stats function that the kubelet already uses to gather information on volume. Okay, so I guess what it is that the kubelet itself exposes a kubelet volume stats metric. So I guess now we have a Prometheus metric for this, and we'll have a persistent. Oh, and it has a label. So for every single claim, that's nice. So now we have this, and so you'll have something like this. So you'll have, so now what you'll have is like this, at PVC1, PVC2, right? PVC3, right? And so on and so forth. So for each one of the PVCs that you have in your graph, in your time series, in your Prometheus thing, you could see, for example, if this specific PVC had a problem or whatever, you'd be able to see it. So you could alert on this stuff when you're monitoring your kubelets and so on and so forth. You might see something. I mean, if I look at this now, is this something that has somebody already like written a blog post on this? Like, I'm sure somebody's made a screenshot of this or something, right? So like, well, we should do this someday. Maybe we could do it. Here, let's see here. Yeah, it's like nobody's demoed this before. That sucks. Too bad. Like, I'd like to see how this is plotted in Prometheus, but if I could grep for it, right? Here we go. Who else is here? Junjin is here. Hi, Junjin. So if folks have any questions, we've got our entry experts. We're going through 124, Junjin. So today we may not harass you too much with ridiculous questions. So, okay, here it is. So yeah, here's the test volume stats collector. Okay, so this is the kubelet collector that has this metric defined somewhere in it. And then here it is. Here's roughly what the metric actually looks like. Okay. So this is the unit test, and we can see in here. So you'll have this metric, and it'll have the namespace, and it'll have the name of the claim. So you could look up exactly what you'll be able to see based on this integer value, right? Where one, and I think that was in the in here, right? It'll have a value of 1 if it's unhealthy or 0 otherwise. Okay, so you expect these generally to be at 0, and if you see that value going up anywhere, then you know that you're having PVC errors. So that's that. There's another CSI one. Let's jump over the CSI one because we don't have all day to look at CSI stuff. But like, what's going on with all these new CSI features? Is this all CSI? Like, okay, storage capacity tracking. This enhancement tries to prevent pods to be scheduled on nodes connected to CSI volumes without enough free space available. How do you know connected to CSI volumes without? Why would you have a CSI volume that didn't have enough free space available, I guess? Storage capacity. And why is this Azure specific, I wonder? Okay, so we're 12 minutes in, so I'm going to try to go fast here. Storage capacity constraints for pod scheduling. So this doesn't seem like it's Azure specific. I wonder. Let's see here. CSI drivers can expose how much capacity a storage system has available via the API server. This information can then be used to the scheduler to make more intelligent. So, okay, we have a new API field. The API field is not in any way Azure specific to my knowledge. But for some reason, the feature gate is. That. What am I missing here? Weird. Maybe it's just. Maybe that's just specific for the Azure, I don't know, cloud provider or something. But I guess the real feature gate is this CSI migration is true. So if you turn on the CSI migration, and that's defaulted to true. Okay. OpenStack. Oh, these are all CSI migration feature. So there must be something special about this CSI migration. So for folks playing at home, I think it's probably worth it if you're interested in this stuff to know what this feature gate is, what this whole CSI migration flag is, because clearly it's relevant to like a lot of the CSI features that are going in. So what's this feature gate all about? You know, if Scott was here, he could tell us. I don't know if he's here. I see 6 people are here, but I don't know if it's Scott is here though. Now, volume populator. Okay, more everything storage. Okay, other stuff. Wait, so are these all storage related? Oh, that's all node related stuff. So I started with node related stuff. So there's so many new features that like I somehow started on 124 because I clicked on something that was 124. I clicked here and it sent me into the CSI stuff, but like Docker shim beta APIs are off by default. I think beta APIs that are not considered stable are enabled by default. This had a good side as it accelerated adoption. However, this opens the gate for several issues. For example, if a beta API bug, it'll have 90%. It'll be on 90% of all clusters. So they've turned that off. So that's new, I guess. Beta APIs are off by default. I didn't know that changed. So that's new. Deprecate and I bet that broke people. Deprecate and remove self-link. Okay, they got rid of the metadata self-link. And I guess didn't all objects have that? I don't know. Like we can kubectl. So I have a kubectl. So for folks that are new, I've shown folks this before. I have this repo here, and I usually on this show when I do things, I go here and I go to JUnit 100 K8s prototypes kind, and I just run this kind local up script and I say, cluster equals Antria /kind local up .sh, and that makes a cluster, just a local kind cluster, and that's usually what we use on this show. Because we don't really do a lot of VMware specific stuff on here. This is supposed to be like kind of a community thing. Sometimes we do Tanzu specific stuff though. So if I look at one of these object get pods -a, let's just edit a pod, kubectl, edit pod. I don't know. Did everything have a self link before? I don't know. So this is new that not everything has self links? So I definitely don't see a self-link here. I don't know if old clusters used to have that or not. But I guess I don't see one here. Okay, 124. It's Kubernetes system components, log sanitization. Okay, some logging stuff. API efficient watch resumption. API server can initialize its watch cache faster after a reboot. Okay, so that's a performance thing. And types open API v3. How does this change things? It serves one schema per resource instead of aggregating everything into a single one. Okay, so that's API hygiene stuff. Okay, then there's the apps API. So max unavailable for stateful sets. So that's going to give you the total maximum number of. So what happens if you when does that take effect? So this is in the last case. So let's make a stateful set. I have a way to do that. We have that also in our demos here. We have a smoke test in here. We can use smoke tests, and I think this one has a stateful set in it. So we can try to create this and see if we get anything. Okay, let me see here. Vim stateful set.yaml. Okay, let me do kubectl create -f that. Okay, kubectl get ss. kubectl get stateful set. So we're going to see already 0 out of 2. kubectl edit web ss. Okay, so this is a stateful set, and we'll see if we can see this new field. I don't know. Max. Let's see if we can see where the unavailable is. So max unavailable stateful set. Oh, its default value is false. So this is that whole thing, right? It's not, it's alpha. So we would have to set that feature gate to true. So in kind, how do you set a feature gate? Kind feature gates. Maybe we could do that by modifying what's in the API server. So if we do docker ps docker exec -t-i, if we jump into one of these nodes, I guess. If I cat etsy, I don't think I'm going to do this right now. But if I cat etsy Kubernetes manifests.
Are we saying that this is disabled because it's in alpha and that new feature where everything is disabled if it's not?
Yeah.
That's
interesting.
That's...
Well, this is alpha, so I think those are off by default. But if it was beta, it would still be default.
Right, still be off. Yeah.
Yeah, this is not beta, so this isn't that new thing. But if it was beta, then we'd get it for free. Right? Or we would have used to get it for free.
But now it'd be disabled.
But now it would be disabled, yeah. So how come I don't have anything in this I thought that every node in a kind cluster had something in the manifest. So I'm kind of surprised here. Like, there's literally nothing in the Etsy Kubernetes manifests. I thought every node had ls Etsy. Yeah, there's nothing in there. That's weird. Okay. So I guess we don't have a... Okay. kubectl get ds-n kube system. So let's look at the dash all. kubectl get ds-a. Who's running this API server? Maybe where is the API server? Here it is. kubectl edit pod that -n kube. Now I'm just kind of curious, like how do we send feature gates? So I'm just going to check. Where do we send the feature gate? Here they go. Okay, so we send the feature gates here, right? So here's a feature gate, and I guess it's network policy endport equals true. I must have set that feature gate somehow. That seems like something that manually I would have set. So maybe this is just my own fault. Yeah, okay, I guess, or maybe Antria sets that. So if you go into Antria CNI so when we use this script, what it uses the Antria utility to do this. Okay. So actually you could sort of hack that up and you could add this feature gate, right? We could add this max and available. We could set this to true, right? So this file is the Antria kind setup script. So Antria has its own setup script for kind that it comes with. So you can git clone Antria, and then you can run this, and it'll create a kind cluster with OVS in it, and then it'll create the cluster. So anyways, I wasn't really thinking about that. But now if we were to kind get clusters, kind delete cluster dash name Antria, kind delete cluster dash name Calico. So we can delete these two clusters and keep going through stuff, and then we'll recreate a new cluster and we'll turn on this feature gate, and at least folks will know how to turn on clusters with special feature gates, because evidently that's a thing now. It's probably more important than it used to be now that things aren't on beta. So add suspend. Okay, so I think we are almost 30 minutes in. So okay. So you can suspend a job. I didn't know you could do that, but that's going to stable. So jobs can temporarily be suspended. So there's a suspend field in the jobs. So if you're running a job, you can stop it. I don't know how people used to stop them. What did they do? Delete the job? Change the cadence? Delete the pod that the job started? I don't know. Track ready pods in job status. CSR duration. Okay, so there's a bunch of auth stuff, couple of auth features. Reduction of secret-based service account tokens. This is a security feature, maybe? Automatically created a service account secret when creating a pod. That token secret contained the credentials for accessing the API. Now API credentials are obtained directly through the token request API and are mounted into pods using a projected volume. Okay, so pods don't... Although these tokens will be automatically invalidated when their associated pod deleted, you can still create the token secrets. So what's the point here? So maybe this has a KEP. I don't know. So there's a token request API, and yeah, I don't know. This is a new thing. Request a token for a given service account. So, okay, I guess the point is it's just more secure because we're not create a service account secret. So there's no...
So you don't have the secret anymore, do you? So you don't have a secret token anymore. You just have the token directly.
You just have a token, and you don't have a secret associated with that.
Which is better, isn't it? It is better.
So did we make a new secret per pod before? I mean, we never used to make a secret per pod, right? I'm confused.
Yeah.
Right? Like, it's not like we ever used to really... Okay, let me go back up to K. Okay, so now let's go in here. Cluster. Okay. All right. So let's respin that Antria cluster. Maybe these were like hidden secrets that weren't listed when you listed them because they were like special API server secret resources. Oh. Wait, maybe... Maybe it just made one secret per service account is what they're saying. Like there was a secret by default for... So, I mean, I'm kind of curious, but I'm going to leave a note here. A lot of times what we do here, Chris, is we just say... We say, if you can figure this out, then we'll send you a t-shirt. And so, t-shirt, This is a T-shirt question. T-shirt. Somebody can figure out. Did we used to make secrets for free? Oh, a meme. Our meme already has a bag of T-shirts. Secret of the service. I think per service account. I already said that, so you don't get a shirt. You don't get anything. Sorry, buddy. Yeah. So they make one secret per service account by default. Do they not do that anymore? I don't know. I guess that's my question. And Meme wants another T-shirt. We can always send you more shirts, Meme. Meme is kind of... He's kind of has more T-shirts than anybody at this point. So...
I don't think they do they? I was looking at this with HashiCorp Vault recently, and I had to do it that second way. I had to get the token instead of the secret.
Because there wasn't a service account.
Yeah. Oh, no, I had a service account, but you have a token for the service account. You don't have a secret with a token in it.
Yeah. Okay. So you had the service account.
I had a token, and that's embedded into it as it builds, isn't it? So it's I can find the link.
Embedded into what?
The pod, isn't it? Isn't it? It's in there. So you make the request to the...
Antonin says this is a big deal. It looks like you're excited about something, Chris. What are you trying to do there? You want to show something? You got a link?
No, let me see if I have one. Yeah.
You want to share your screen? We could do. The world is yours.
Yeah, let me find the link first. Make sure I'm talking about.
All right, you keep looking at that. I'm going to go forward. So, yeah. Ricardo, network policy status. Alpha, he finally got it in. So this is something that came about because of all the debates around port ranges, and Xilium didn't support them, but Antria did, and Calico did. And so we needed a way to publish metadata about network policies. What network policy APIs were and weren't supported. So finally we have that field. So thanks to Tim and Ricardo and everybody else who worked on that KEP. And as you can see in Antria now, when we spin, it actually sort of enables that. So the other feature gate, I guess we would also want to enable, what was the feature gate we were enabling before? It was the port range, right? So we may... if somebody wants to, in the CI Antria script, we may want to, well, I guess it doesn't matter because Antria will look for those. Where is it? Here it is. Here's the feature gates. So... this is the feature gate. Here it is, network policy status. So we may want to ungate. We may want to enable this feature gate too. Oh, wait, did it overwrite my... So we may want to, if you're doing the Antria CI kind script, you may want to play around with that too. Will allow users to receive feedback on whether network policy and its features have been possibly parsed and help them to understand. So I'm not sure how that feedback is supposed to be provided. I guess the idea is that the status field, and then I think after this we should look at the KPNG KEP. So the status field is something that the CNI itself can... Like, how would we query it? So it's inside of the, okay, so there's a network policy status. So there's a network policy, and then inside of the network policy, there's now network policy status. And I suppose the CNI provider needs to have right. I don't know. I assume the idea here is that CNI, let's look for, I'm sure somebody wrote. It's up to the network policy provider to decide how this feature is going to be implemented. And this can be even an early admission webhook, right? So this is some status metadata, and I suppose that status will just get updated by the network policy provider. So like, for example, does that mean, I guess Antonin's here, does that mean, Antonin, that we update this field in Antria? Maybe we do. Like if I look for network, see status. Let's see. Do we use it yet in Antria? Let's see. Yeah, Chris, if you want to interrupt, here we go. Yeah. It does look like we are using this in Antria. Oh, I don't know if this is the same thing. Control plane network policy status. I don't know if that's the same. I bet you anything, though, our friends at Antria probably did a good job filing this issue, right? That we need to implement this somehow. Okay. Here we go. Support for network policy status. So here we go. Quan went ahead and implemented this. Proposal is expose the status of Antria policies to the status field corresponding to. Oh, this is, yeah, here it is, network policy status. So he took that from the KEP. Besides, the Kubernetes API uses generation as part of the track generation of the desired state. Automatically when changing, okay, this proposal looks great. Okay, so evidently 1442, they implemented this network policy status. Folks want to know how Antria implemented it. That's where they did it. Oh, no, you don't implement it yet, but we are working on upgrading our client Go dependency 120 first. So, okay, we don't update, but guess what? Antria implements all the Kubernetes APIs for network policies. So don't worry about it. Maybe some other CNI providers may need to. So, but may need to worry more about this, but not us. So, I think that's probably good enough of a review of the 121. Well, I mean, let's at least go to Windows, right? How can we do? Okay, scheduling is so stable in Kubernetes that we're going to skip it. They're just always adding great stuff to it, though. Other enhancements: kubectl return code normalization, sub-resource for support in kubectl. Get patch 8 will now contain a flag sub-resource, which will allow fetching and updating status and scale sub-resources for all API resources. Oh, okay. So, like get patch edit. So that would mean I would kubectl. Oh, so you don't have to do like a curl where you have a huge. Is it that patch now doesn't require a huge JSON payload at the end of it? I don't know. Okay, so now service type load balancer graduating to stable class.
Yeah, this is interesting because this comes from us as well. This was Zudong and his team that created this, and it's almost like an ingress class for load balancer service. So in like a AWS use case, you could specify it not to use ELB and use, another load balancer, for example. So it's kind of interesting.
So what leverage multiple service type load balancer cluster type? Isn't that gate? Okay, that's not a gateway API thing.
No, it's separate to.
This is an L4 thing. Okay.
Yeah. I have a good
okay.
name, actually.
Yeah. What did we do here? I didn't know we were doing this. Great. Thanks.
Yeah.
Thanks, Zudong.
Yeah, new thing. It was kind of quite neat.
Oh, this came from the cloud provider stuff. Yeah. This has been around. Okay. Yeah, this has gone back a long ways. Folks have been working on this. Andrew worked on this, and then this came out a while back, and now it's stable. So Zudong helped finish making it stable, it looks like, and worked on it for a while. Cool.
Yeah, it's relevant for me as like a AKO person because now in in the cloud load balancers, we don't have to use the native load balancer or the use cases like that.
Yeah. Okay, cool. Well, great. Thanks for folks who helped move that to GA. So, Okay, cloud provider stuff. Here we go. Here's one. I mean, memes here. Windows operational readiness. So this is another one from us from over here at VMware. Meme and Chinchi doing this one. I worked on this one with them. This comes from Sig Windows, giving us a real definition of what a Windows Kubernetes cluster is and what it means to make it conformant. So we're very proud about that we finished that, and we're implementing that now. So if anyone wants to help Chinchi, she'll be on the show next week. Let's go. Let's get out of here. Let's go do our KEP. So one of the things we have, so as you know, we've talked about it this on the show several times, the KPNG project. This new project where we're trying to rebuild the entire kube proxy to be pluggable. And so for people that are new, I'll show you the diagram, the overall architecture. I'm not going to dig deep into it because we've gone over it so many times on the show. And there's so many people, like Rajas is doing a KubeCon talk this week about it, or a Rejects talk, and there's other folks. There's a lot of ways to learn about this now. We've done 2 TGIKs on it. But overall, it separates the thing that talks to the API server, right? It separates that from the backends that write load balancing rules. So this is our update to this is our new version of the kube proxy. And so we have all these backends now, right? And Rajas just finished getting the user space port working. So the upstream user space Linux and user space Windows are both now working in KPNG, which is great because it means we can now really deprecate the user space proxying in tree. Really kill it for good. But anyways, we're working hard on Windows. I'm working on that with some other people, Matt and Doug and stuff. Now, here's the thing. We have this all, but Dan Winship was like, when are you all going to update the KEP? Because the KEP is just a total disaster. We haven't looked at it in like years. And so that KEP is... so let's look at that enhancements KEP, and let's look at the comments and see how far we can get. And if folks are sort of have never worked on a KEP before and want to sort of help us to finish this, we'd love anyone to help us to finish this off. So it needs to be rebased onto the new format. Also, the KEP is as much about moving kube proxy out of tree as it is reworking its architecture at this point. So the first thing we need to decide is what this KEP is going to be. Antonin, I've left your comment up for a while. Here we go. What happened? I don't know when I don't know which issue that was. I was late looking at the comments, so I kind of lost track of that thread, Antonin, but feel free to post any updates that I need to the comment, and I'll post it. But also this KEP is much about so one of the things that this KEP is saying is like, so it's about moving the kube proxy out of tree, which is great because the in-tree kube proxy, Kubernetes, GitHub, is a big mess. So inside of Kubernetes, you go and you dig into it, and you go into here, and you go into proxy, right? And you'll see there's all this stuff in here, and each different technology that you can do a kube proxy on has different directory, and these are huge directories with all this tons of code in them, and then each one of these normally runs a watch. So like on Windows, you're running a watch onto the API server, and that watch takes up resources and so on and so forth. And KPNG, we split all this out, so the thing watching the API server doesn't actually even need to be running on the same thing that's routing the rules. So for example, you could have a Windows kube proxy that literally just wrote HNS networking rules and had no connection to the Kubernetes API server, and it would just read the gRPC from KPNG. So it's a much faster, cleaner implementation of decoupling the data model for Kubernetes from the networking model that Kubernetes needs from services to pods. So we need to decide that, right? So this is one of Dan's comments is like, are we talking about moving kubeproxy out of tree, or are we talking about just reworking its architecture? And I mean, I think I'm going to suggest, would it be okay to say kubeproxy out of tree will be the place where new features land? And someday we'll move one. Do we want to say, or two, KPNG in tree will replace the in tree kube proxy? So there's basically two ways to go about this. We can say that KPNG eventually will replace this directory entirely, or we can say that it will. So I don't really have an opinion there. We'll see where Dan responds on that. And Rajas is going to start working on this KEP also. But so we need to rebase it, and so let me bullet this. Part 2. Part 1. Rajas Kakadar, do you want to rebase this one? Because I know he wanted to sort of clean up this KEP and finish it. Let's see what other comments there are. This sounds more like the original model where there's going to be a daemon, as opposed to what I understand to be current, where the shared code is more part of the library. Or am I wrong? This KEP is born from the conviction that more decoupling of the service object and the actual implementation is required by introducing an immediate node-level abstraction provider. This abstraction is expected to result in the more like the original model. I don't understand this question, really. This KEP is born from the conviction that maybe we just need to delete this sentence. I think we can delete this sentence. It's the implementation itself should stand to explain the architecture, and the simpler, more stable API part is just a nice to have, is not essential to this KEP. Maybe. So I would say we can just delete this sentence. If it's causing confusion, we can delete it. Now, this looks like a huge debate. What is the scope of this? Allow easier, more stable proxy implementations that don't need updates when service business logic changes. So the idea here is that, like, if the service API changes, so if I say kube, so let's see here, let's open up a service object, right? kubectl get service -a. kubectl edit service kube system. Okay, so let's okay. So I've got this service here, and I guess the point that's being made there is that we're saying, say that any of these fields change or whatever, we don't want to have to change the way our, if I have a back end, like in here, let's take Windows, my favorite, and let's take the proxy in here, and we don't want this to have to depend specifically on the API types inside of the service. So, and in KPNG, we don't need to do that anymore. We don't have to import the the Kubernetes service types at all. And we can have whatever data model we want for our network. And the thing, I should pull up that SVG, right? So the thing that mediates all that for us lives out here. The global model, right? So that global model, if you look at it, the data model that we're actually using is this. Okay, it's this very simple YAML model. And this is the only thing that any backend in KPNG ever needs to read. Okay, so if I go back here, again, this is similar to Dan Winship's comment in that it's like, okay, we didn't really properly explain what we mean by this idea of a stable proxy implementation. The question is, what is the scope? I think today kubeproxy implementations are all doing this to some degree. Do we expect all of them to get to this point, or only the first one or two? I think for scope, kubeproxy will only provide information about services and endpoints, maybe network policy later, probably not ingress. Tricky thing is, if it doesn't provide enough information, that it'll either be completely unused or watch more resources. For example, if we can pre-compute some flattened API from service and endpoints, but we actually need some info from the endpoint that isn't the flattened resource, we would still need to. That's a good point. Right now, we don't have that problem in KPNG. You can run a full proxy and nobody has to watch anything. The network policy thing I get, but I don't see how that's a big deal because that's implemented by the CNIs. That's not implemented by the proxy. I think this comment, service account needs. Just to clarify one thing, you need the service account endpoint, and my API is only a target endpoint. You may reference the source. Yeah, okay, so he's saying because Istio uses the service account when making service mesh decisions about whether to route to something or not, maybe. I don't know. So it still needs to watch the API server. I mean, it's a fair point. Okay, touche. So there's other things you might need to watch. So what the overall point being made, I think the overall point is we can't wrap the entire K8s API in the KPNG data model. And that's a fair point. That said, for proxies, we do wrap enough that the base network functionality works for service routing. I think that's good enough for a V1. So my answer to that is yes, you can't wrap the entire Kubernetes networking relevant information into a pretty struct the way we have for other things in KPNG, but that doesn't mean we shouldn't do this. Okay. Okay, we got 10 minutes left. So, by the way, Chris, I know this is all totally randomly new stuff, and if you have questions, you can totally interrupt me. And let's see, Ricardo's laughing at me because I always tell him how much I hate writing KEPs, and now I'm writing one on the internet. So, is this still part of the plan? So now Dan is asking, include equivalent implementations of in-project ones, user land, IPVS, optional help proxy implementations of the same subsystem to cooperate more easily. Help proxy implementations using the same subsystem. So, like, are we unifying libraries? We currently have IP tables code copied into the IP tables backend so it can be hacked up separately from other places. we currently have boilerplate from upstream copied in as point in time libraries so that they can evolve independently and eventually we'll remove all the IP tables logic and replace with full state. I don't think we are trying to cooperate subsystems right now. Instead, the focus has been on quickly getting conformance to pass as a POC for all backends. Happy to remove that bullet or keep since it's optional. Oh, actually, no, that's not true because we actually are doing that for contract. I take this back. We're building a contract subsystem that can be applied by any backend for cleanup, right? Because there is a contract. So to some extent, yes, this is part of the current plan. So yeah, actually, we are doing something in KPNG so that any backend that needs to clean up contract tables after routes endpoints come and go will get replaced. You can remove the comments where you filled. Okay, that's an easy one. Is this still the plan? If so, why? Rewrite the kube proxy to be a localhost gRPC that will provide access via. Right now, you can run it in memory or over localhost, all in one process in memory or in localhost. So, because when we run KPNG now, you can send it using the to API and to backend flags. Check out I have to double check though that we don't sneakily just use 127 in the to backend implementation. So technically when you start KPNG right now, you don't have to run a separate you don't have to run the backend separate from the thing that watches the API server. You can run it all as one. But I don't know, there could be some weird hack where maybe when you do that, we still actually serve everything on 127. So I'll have to double check that. But it's a good question. Does not require rebuild release. Seems like a dubious feature in general. Any interesting loop is going to be getting new features of its own as well. So rebuilding release anyway. This decoupling allows kube proxy to evolve in their own time frames instance. Yeah, like as an example, the endpoint slices, that didn't affect the backends at all because once endpoint slices were introduced, they just went into the the thing that creates this data structure, reads endpoint slices and creates these data structures and then sends them to the backend. So endpoint slices, for endpoint slices though, this approach resulted in no change to backends. It worked for endpoint slices though, i.e. yeah, because the endpoints are sent, and so now we're at 4:58. We've got 2 minutes left. So Ricardo loves KEPs. So that's like just the very beginning of us starting to rewrite this, sort of cleaning up this KEP. I'm going to be working on this with Rajas. If anybody wants us to help finish the KPNG KEP up and move it to production to get this, the tests we run right now, this is a good thing he mentioned. So right now, the CI that we run, SIG network, we do something like this. And so right now in CI, we run something like that. We run all the SIG network tests roughly. And these are mostly passing. We don't have explicit scalability tests that we run yet, though. If there's a large scale one-time kube proxy scale test we should run. Let us know. Maybe something in kube. There's a kube loader project. There's a 100-node CI job that runs also for upstream. So maybe that would be a good enough test. Maybe CI is good enough to catch things, but rewriting the whole kube proxy is a pretty ridiculous thing. So who knows what bugs you might introduce, right? Okay, I'm going to call it. It's 5. Chris, any final words for your new friends?
No, it's good to meet everyone, and thanks for the invite, really. It's been an interesting hour. I didn't say much, but an interesting hour all the same.
Yeah. So, okay, so Chris is going to start helping us and hosting some shows and alternate with me and Chinchi. So big thanks to Chris for helping us, because we've been doing this forever now, and we're almost on our 30th episode, and we need help, and it's just great. So I just really appreciate you jumping in into the fire with us here, and so we're looking forward to learn a lot of stuff from you and get to know you here. So this is our own little community that we sort of created from scratch, and marketing. There's no marketing. There's no anything. It's just us hacking around every week. So.
All right.
If anybody wants to do a show with Chris or whatever, you know where to find us. We're all on Upstream Kubernetes Slack. You can leave a comment on the YouTube show, whatever, or with me or with Chinchi, and we're always happy to host a show with you. Thanks a lot, everybody. If you enjoyed this show, like and subscribe so we can tell our bosses that we need to keep doing it every week. All right. I'll see y'all later. Thanks, everybody.